Hello and welcome to the video on IPv6 addresses. Hopefully you've taken a bit of a look at IPv4 addresses before you've got to this section. If not, I recommend you watch the IPv4 addresses video before you watch this one. So before we get into the details about IPv6, we want to look at why we need IPv6. So we've been looking at IPv4 addresses quite heavily. And what we know about IPv4 addresses is that they have 32 binary bits. So when you have 32 binary bits, each bit can either be a 0 or a 1, which means there's two possible states for each bit. So the total address space is 2 to the power of 32, which is about 4.3 billion. Now when we look at a planet that has around 8 billion people, and we look at the ever-rising number of devices that each individual person has, not to mention IoT devices, so we're having kettles, lights, toothbrushes, cameras, soccer balls, and various other things with IP addresses or other networking capability, we're starting to get well beyond 4.3 billion needed addresses. So we're moving to what's called IPv6. Now, we actually ran out of IPv4 addresses a while ago, but there's no official move to full IPv6. There's 3 protocols that have been put in place that allow us to have the coexistence of IPv4 and IPv6, and also to help mitigate those issues. So the 3 protocols you're going to see quite often are dual stack. This one you'll see in most scenarios. This is when IPv4 and IPv6 are coexisting. So that means that both IPv4 and IPv6 are configured on a single network. The next protocol that you'll see quite often is called tunneling. Tunneling is essentially a way of wrapping an IPv6 addressed packet in an IPv4 address so that it can go through an IPv4 section of a network. So if you have a IPv6 packet, right? So we have this little IPv6 packet, it's addressed that way. We essentially are wrapping it again in an IPv4 for the purpose of it going over a section of network. The other common protocol you'll see is called translation or NAT. So that would be for network address translation. So in network address translation, sitting at boundary edges, so it could be at the outside of your ISP, it could be at the borders of countries or the borders of certain networking spaces, they are handling all of the translation. So essentially, they're creating a list and manually assigning, well, not manually, but a server or computer or NAT-enabled device, NAT router, is enabling the conversion between IPv4 and 6. So it's converting. And it's essentially creating a network with a set of addresses and another network with a set of addresses and pretending they're the same. This is why you could have an address that's 192.168.140.2 at home, and we could have that here at the school network, but they're not the same IP address. The IP address is determined by the ISP, but essentially it's creating like a fake internal network set of addresses that's separate from the external net of addresses, which allows us to have this conversion. So when we're looking at representing IPv6 addresses, so IPv6 addresses are actually made up of 128 bits, and that's a lot of bits to write, so they're represented in hex notation. Hex is base 16. Notation is base 16, which means that we have possible binary or possible digits for hex being anywhere from 0 all the way to F. Oops. Sorry, we don't have a 10. We go A, B, C, D, E, F. So those are the base 16 numbers. The base 10 equivalents would be the same for the first 10 digits. Oops. Saying and writing numbers at the same time. And then 10 would be A, 11 would be B, C would be 12, D would be 13, E would be 14, and F would be 15. So you can see that we have 0 to 15, which is a possible 16 digits, which is so there's 16 possible digits in the base 16 system. Now the easiest thing to do when you're converting hexadecimal is to convert hex to binary or binary to hex. And the reason for that is that it's quite a simple conversion. So if we have hex, let's say we have the number 2 in hex, we can represent it in 4 binary digits as 0010. So it's just the number 2. If we have 5 in hex, we can represent it in binary as 0, sorry, grabbed an extra digit there, 0100. That's 4. 0101. So you can open the Windows calculator if you find that's helpful. It'll actually show you hex and binary conversions. But what you need to know is that the nice thing about hex is in this this single digit space, the highest number F matches exactly to 4 binary ones. So when we get to multiple digits in hex, we simply are able to put 2 sets of 4 digits together. So if we want to write it as an 8-bit binary number, we can simply say, okay, if we have 1100, 0101, we take the first portion of the address, and that's 8 plus 4. If we look at it as a 4-digit binary number, we get 8 plus 4, which gives us a total of 12. And if we look over here at this one, as a 4-digit binary number, we get 4 plus 1, which gives us 5, which means that in hexadecimal, we can represent this number as C5. So we simply take the 4-digit binary and put them together. So if we have the hex value AB, we know we're going to need the binary for 10 and the binary for 11. So the binary for 10 is going to be 8, no 4 plus 2. And the binary for 11 is going to be 8, no 4 plus 2 plus 1. And so the binary representation is simply that. So if you want some practice with that, there's a hex game that you can access, and it will allow you to get lots of practice with the hex to binary conversions. They should be a bit of a reminder to you from previous notation. So I just want to remind you a little bit about hex, because as I said, we're going to look at the IPv6 128-bit in hex notation. So let's look at an IPv6 address. So when we're looking at an IPv6 address, we quite often will see an address such as
2000DB8:00001111:00000000. I'm just going to fill the colons in after a little bit so I can build up some speed here. 0000 and 0100, let's say. Okay, so you'll see here that we have groupings of 4 hexadecimal bits, which means each one of these is worth 4 base 2 bits, so 4 binary bits. So in total, each section is 4 binary bits, 4 binary bits, 4 binary bits, 4 binary bits. So this whole section is 16 binary bits, which is why an IPv6 address can be 1, 2, 3, 4, 5, 6, 7, 8 sets of 16 binary digits. 8 times 16 gives us 128 binary bits. So as you can see, it's written in base 16 for a reason. It's quite complicated, or it's quite a long address. We'll also look at how we can shorten addresses. So there's a couple of rules we can use when we're writing out IPv6 addresses in shortened form. So when we're writing them out, the first thing we can do is omit leading zeros. What does that mean? It means anywhere where we have values, and there's a 0 at the front, we can get rid of that 0. So we can get rid of that 0, we can get rid of that 0, and in fact, we can get rid of all of the zeros. So we can get rid of all of the zeros that lead off a number. So in this case, we can get rid of all 3 of those zeros. We can get rid of all 3 of those zeros. We can get rid of all 3 of those zeros. We can get rid of all 3 of those zeros. We need to leave a value in each section of bits. So we are going to go ahead and keep those digits, this 0, this 0, this 0, this 0, those digits, and obviously the ones that don't have leading zeros will remain the same. So we have a slightly modified form of this address now. Now we can write it as 2001 colon DB8 colon 0 colon 1111 colon 0 colon 0 colon 0 colon 100. So it's a little bit shorter than it was previously, but it's still quite long to write out. What you'll notice is we have this section with these 3 zeros. What we can do when we have multiple zeros in a row is we can collapse them using just a double colon. So if there's multiple zeros in a row, we can get rid of them. What you'll notice is that we can't get rid of this one, and I'll show you why. So we get 2001 colon DB8 colon 0 colon 1111 colon, and we're just going to collapse out this whole section, because we know that whenever we have a collapsed section, it's filled with zeros. 1 0 0. So that whole collapsed section was just left here, and the colons on either side remain. Now, why can't we do that to this 0 here? Well, the reason is this. If we write this address, we know that there is 1, 2, 3, 4, 5 sections, so we're missing 3 sections, and all of those sections need to be made up in the collapsed spot. So that means that that has to be all zeros, and we know there's 3 sections. If we were to write this address as 2001 DB8 colon colon 1111 colon 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 100, what you'll see is that this address could potentially expand into the address it came from, which is good, but it could also expand into a couple other addresses. It could be 0000 colon 0000 colon 1111 colon 0000 colon 0000 colon 100. So it still allows us to have 1, 2, 3, 4, 5, 6, 7, 8 sections, but in this case the zeros have been misrepresented. We have 2 here and 2 here instead of the 1 here and the 3 here that this represents. So we need to make sure that if we're collapsing into a double colon, we're only doing it in one place, and usually we're removing the larger section of zeros. So there's some activities on Netacad at 7.2.2.4 that will help you to practice these IPv6 conversions and writing them in compressed format, which can be quite helpful when you're getting used to the compressed format version. Just some things to note is that this whole, when you're putting it into single colons, you can only do it in one place, and that you can always omit leading zeros. That's pretty much the main ways in which we're going to collapse IPv6 addresses. So I will be making a second video on IPv6 address, specifically looking at the different types of address types and casting, and how we're going to look at the prefix length, any sort of binary work we would need to do with this, link local addresses and that sort of information. But I think this is enough content for one video. So it's a reminder of IPv4 and a little bit of a look at why we need IPv6. Some look at the 3 crucial IPv6 protocols that exist. IPv6 is written in 128 bits in hex notation. How we convert from binary to hex, which again, there's some practice activities and there's a game you can play to practice that. And then how we can compress IPv6 addresses. And you do want to practice compressing IPv6 addresses and decompressing IPv6 addresses so you get a little bit more familiar with it. But that's a summary of what this video is. And in the next video, you'll learn a little bit more about IPv6 addresses.